Hello. In the past, we have talked about linear functions and patterns. Today, I'm going to compare those with nonlinear functions and patterns. We'll put some side by side. I'll show you some different types of graphs. So, in the first graph, we're going to talk about the radius of pizza compared to its area, or how big the area is going to be based on the radius. So, let's say you have a radius of 2 inches for a pizza. Its area is going to be about 12.5 square inches. If your pizza's radius of 4, the area is going to be about 50 square inches. If the radius is 6, it'll be about 113 square inches. And then I'm going to put 2 more here. 201, oops, that's 0.06, excuse me. And 10 is 314.16. Keeping in mind the formula for area of a circle is pi r squared. That's how we're getting this information. So the graph of that is going to look nonlinear. Let's do it. So a radius of 2 has an area of 12.57. So it's going to be really low down here. Let's see, it's probably about right here. A radius of 4 is going to be 50.27, and you'll see in a moment why I spaced out the graph like this, because it's going to get big pretty quick here. Radius of 6 is 113. It's about here. Radius of 8 is 200-ish, just a tad over. And the radius of 10 is 314, so that's going to be about right here. So notice that this is not a straight line. These kind of go in a curve up this direction. Just kind of like that. All right, now I'm going to do a weight of sauce versus the cost of the sauce. So this is how much sauce you're putting on a pizza. So if you put 2 ounces of sauce on a pizza, it's going to cost 80 cents. If you put 4 ounces, it's going to cost $1.60. If you put 6 ounces, $2.40, and 8 ounces, $3.20. So you can guess before I start graphing this, is this going to be linear or nonlinear? Maybe you can tell by the chart here. So 2 is 0.8, so that's going to be about right there. 4 is going to be 1.6. So that's going to be about, let's see, about right here. 6 is going to be 2.4. Should be about here. 8 is going to be 3.2. So that should be about here. As you can see, this is linear. These line up. My hand's not perfectly steady here, but it is actually linear. So if we compare these side by side, let's see, you can see this one kind of curves up here, and this one goes straight. Let's try another one. Let's go back to not full screen, oops. There we go, single page. So we're going to go to the last one here. We're going to talk about the volume of a cube. And we're going to start with a side length of 1. The volume of a cube is side cubed, all right, like a die. You have 3 sides. So a side of length 1 is going to be a volume of 1 because it's 1 times 1 times 1. For 2, it's going to be 2 times 2 times 2. For 3, 3 times 3 times 3. 4, let's see, what is that? 64. And for 5, it's 125. And for 6, it gets pretty big. I don't know what that is. 36 times 6. So is that 182.16, I think. Alright, so let's graph this. So we have a side length 1, volume of 1. So that's going to be way down here. Side of length 2, volume of 8. That's going to be about right here. I'm going by tens on this one. 327. right there, 464. About right here, 5, 125. It's really starting to shoot up now. And then 6 at 216. So that's going to be probably above the graph here, probably around here. So as you can see, this one really shot up fast. And when you graph these, you need to make it kind of curve up. Don't connect the dots with straight lines. It's actually a curve. So you can kind of compare the different graphs we have here. This one kind of curved up, pretty similar to this one. That one's a straight line. And as you can see, the number, the exponent, actually makes the graph rise a lot more. And so you'll see in these exponential ones where r squared, the graph is going to curve up. Whereas if there's no exponent, in this case, it was just the weight times what? 0.4. The weight times 0.4. So it's cost equals 0.4 weight. So notice there's no exponent here, so it's going to go up in a straight line. We'll talk more about these in class, and there's other types of graphs we can look at as well. Thanks for watching.